So let us move on to next topic in our textbook, that is simplification of incompletely specified functions. So here in this method also, to solve the problems we are using Quinn-McCluskey method. Okay. So incompletely specified functions means it includes the don't care conditions as well. So let us take one problem here that is represented with f of a comma b comma c comma d, that is equal to summation of mean terms 2, 3, 7, 9, 10, 11, 13 with don't care conditions, that is summation of don't cares 1 mean term 1, 10 and 15 is being included. So here the don't care terms are treated like required mean terms when finding the prime implicants. So we have in these particular problems, when you are solving the incompletely specified functions, we have to consider these don't care conditions also as the mean terms that has to be included in the Quinn-McCluskey method. Okay, so don't leave that don't care condition. So you can see here in this particular problem you have mean terms 1, 10 and 15 as a don't case. So this has to be included in the problem while you are going to solve. Okay, don't leave this because this also has to be included. So let us see the Quinn-McCluskey method. So as you know, in the previous slides we have discussed about the Quinn-McCluskey method and how you can solve the problems all you have learned. So you can see that there are certain numbers here in this particular column, that is 1, 2, 3, 9, 10, 7, 11, 13 and 5. So based on the mean term binary notations, we have classified into different groups. So the first group, if you are going to see here, it has a single number of ones. Is it only one you have here? Here also one. So these are the mean terms. Whatever this particular column, whatever you have written is mean term. The decimal, sorry, this is a binary notation of the all the mean terms. Is it? So here, next group, if you are going to see here, the second group, you can see that there are two number of single ones. Okay, two number of ones you have here also, two number of ones, two number of ones, and three number of ones you have here, three in this group. Okay, that is third group. If you are seeing three number of ones you have. Next group has four number of ones. So based on that we have grouped different mean terms, and later we have started to solve the problem. So when you started solving the problem, you are going to combine certain mean terms. That is here, as you have learned in the Quinn-McCluskey method, I am going to combine 1 and 3 because here it's going to match 0 0 0 0 of first mean term is matching with 0 0 of third mean term, as well as 1 of the first mean term and third this is the one more mean term is matching here. So here if you are going to see, that is one variable is only being changed, is it, that is 0 to 1. So that particular thing we are writing it as dash in your problem. So like this, in this the same manner we are going to write other combinations. So here first, if you are going to see 1 3 combination 1 9, next you try to combine other terms and you will be writing 2 3 2 10 3 7 3 11 like this. So these are the different combinations. So as you have matched these terms or these mean terms, you have tick marked these mean terms, is it? So next step is in one group. Here also we are grouped in the same manner as we have done here in the first stage. In the second stage also you are going to group based on number of ones, is it? So you can see single number of ones in this group, double number of ones in this group, again three number of ones in this group. Okay, so as you have done in the second stage, we move on to the next stage, that is stage 3. Here also we try to combine certain mean terms, and what we are going to do here is, see here, let us see 1 3 I am going to trying to combine with 1 9, it was not possible. So 2 1 3 I try to combine with 2 3, 2, 10, that was also not possible. So when I tried to combine 1, 3 with 9, 11, it was possible to combine. That means here 0, 1 of 1, 3 combination matches with the 0, 1 of this particular mean term, is it? And 0 changes to 1 here, so that can be written as dash. So that is what is represented here. So 1, 3, 9, 11 was the possible combination in the third stage. Okay. So in this same manner, 2, 3, 10, 11 was possible to combine, and 3, 7, 11, 15 was also combined. 9, 11, 13, 15 also was also combined. So based on the combinations, we had ticked the mark in the second stage. After that step, again if you are trying to combine, you are not able to combine the terms, so we left out. And there are 4 terms which are not being tick marked. Okay, so this will be taken into consideration, or we call these terms as the sorry, not essential, it is a only the prime implicates we are going to choose for the next step. That is, we have to write the prime implicant chart, is it? So that's why we are going to include this particular terms in the next stage. So remember that 1, 3, 9, 11, 2, 3, 10, 11, 3, 7, 11, 15 combination, and 9, 11, 13, 15 combinations are the different combinations we are going to consider for the next coming chart. So simplification of incomplete specified functions, that is continued here. Now let's take the prime implicant chart. So here, if you are, as I said, what you are going to write here is the prime implicants which was there in the previous slide, and also we are going to write the mean terms here. That is 2, 3, 7, 9, 11, 13. So we have included here only the mean terms, which was present as a summation of mean terms 2, 3, 7, 9, 11, 13 was there in the function ABCD. Is it? So you had also some terms, that is don't care conditions, which was the don't care condition ones 1, 10 and 15 was the don't care conditions there. Is it? So here these don't care mean terms we are not going to include it to the prime implicant chart, that you have to remember. So the don't care columns are omitted when forming the prime implicant chart, that key point you have to remember here. Okay, then rest all method is same as you have done from the Quinn-McCluskey method. So here what we are going to do, initially we are going to mention what are the meters. One is not present here, is it? So we have not written 1 here, so don't take that. 3 can be marked here. Okay, 9 can be marked. 11 initially has to be marked, and 2, 3, 10, 11 you have 2, 3, 10 is not there. 10 is a don't care condition, leave that. And 11 you have, that you have to tick mark. And 3, 7, 11, 15, that is 3, 7, 11 and 15. 15 is the don't care condition, don't mark it. 9, 9 initially 9 has to be, then 11, 13, 15 you have. 15 is a don't care condition, so don't include that. Okay, so now what you have to do, the first step in solving the prime implicant chart is you have to encircle the single ones that is present in the columns, is it? So you can see that here this term and this term and this particular thing are I'm going to encircle it, since it is a single term you find in the columns, is it? So that is the first step. After first step, as you have marked here, actually that mean term 2 is being marked, right? So that's why the column so in the row, whatever the terms you have are also being considered to the final equation. So I mark here this as the essential prime implicant, since it was included here. Okay, and next thing is, as I have encircled this, the other terms which are in that same row are also being cut off, and I am going to take the next essential prime implicant as 3 7 11 15. And after this particular step, if you see one more term you have encircled here, since 13 is being marked, I am going to mark the other terms in the particular group. That's why I take 9 11 13 15 also as a essential prime implicant. So now I have in this particular problem I have got three essential prime implicants. Okay, so this will be included in the final expression. So what is the final expression? We are going to write that is 2, 3, 10, 11. If you are going to see 2, 3, 10, 11 was what it was? It was dash 0, 1 dash. Is it? So B, C, D, four variables you have. Is it? So what is B? B is B bar, B bar, and C is 1, so that's why B bar C. And next thing is 3 7 11 15. You have 3 7 11 15 was dash dash 1 1. Okay, so dash dash 1 1 means it is C is 1, D is also 1, so that's why I write it as CD. And next you have 9 11 13 15. 9 11 13 15 is in the from the previous slide we get it as 1 dash dash 1. So here it is A and D, is it? So so these terms I am going to write it in the final expression. F is equal to B bar C plus CD plus ED. Let us move on to next topic, that is simplification using map entered variables. So this kind of problems is actually appearing in the lab. Okay, it is one experiment you have that is using multiplexer. So in that particular lab experiment we are going to use this kind of map entered variables. So it is very important in case of lab, but in theory there are less chance of getting this particular question in the exam. So it is very important topic in case of lab. You have to know how to write the map entered variables. So earlier we have solved problems on Quinn-McCluskey method and also Patrick's method to get the minimum form of expressions. Is it? So Quinn-McCluskey method was used to solve problems which had more than 4 variables. Is it? But getting the solution in that case is also very difficult because you have to encircle the rows there, and you have to see how you can get the essential prime implicants and all. So that's why they went for the next method, that is called as Patrick's method. So in that Patrick's method it was very easy to get the solution within few steps. Means we have to apply few formulas as well as distributive law, and we were able to get the solutions there. And we have also solved the incompletely specified functions which included the don't care conditions in case of Quinn-McCluskey method. Now we have something called map entered variables. So you have to know what is this map entered variables. So some variable is being entered into the K map. Okay, so that is the thing you have to remember here. So one of the input variable is placed inside Karnaugh map actually. So you know how to solve Karnaugh map. As I said in the earlier slides, we have gone through the K-map simplification to get the minimum expressions. So this is if you know to solve Karnaugh map, you can easily solve this map entered variables. So this reduces the K-map size by 1 degree. That means what you say, you have 3 variable problem. Is it 3 variable means it is 2 raised to 3. You have 8 locations in the Karnaugh map. Is it? So we are going to reduce one variable. That means 2 raised to 3 minus 1. You will be getting 4 locations on the K map. So that is the use of this map entered variables. You are going to reduce the variable by 1 degree. Okay. So this technique is particularly useful for mapping problems with more than 4 input variables. So let us move on to the problem. So let us take one example, that is y is equal to f of a comma b comma c, that is equal to summation of mean terms 2 6 7. Okay, so if I write the truth table for this particular problem, I am going to get the problem as this. Okay, A, B, C, D. A, B, C is the variable you have, and Y is the output. Is it? Y as the output variable. Is it? And these are the input variables. Input variables. So what mean terms? Mean terms are 2, 6 and 7. So mean term 0th position, 1, then 2 position you have here, 6th position you have, 7th position you have here. Okay. So now this is truth table you have written here, and for this particular problem, and next you have going to write the entered variable table. Entered variable table. Now you have to understand how to write this. Okay. So consider that I am going to consider two variables as the input and one variable as the output. So as I said, you are going to reduce the map by 1 degree, is it? So that's why we had three variables initially. If you see here, you have three variables A, B, C as a three variable. So I am going to reduce it to two variable now. Okay, and the extra term, what happens to this C? Now you may think, what happens to this C? C will be entered in the output side. Okay, C will appear here at the output side. Okay, so that is what we want to do here. So let us take now, let us look upon the problem now. So here, let us see here, A AB 0 0. Okay, here also 0 0 you have. Okay. And here two combinations, A has got 0 0, B also has got 1 1. Okay, that you can take. And here if you are seeing, AB has got 1 1 and B has got 0 0. So this is one more term. And this fourth one is A variable has got value 1 1 and B has got 1 1. Okay, so now the same thing will be entered in your entered variable map. I'm going to write the same thing over here. Okay, so what is this? You have here 0 0, is it? The first combination, if you are going to see, let us see this particular thing. A is 0, B is 0 every time. Okay, so that means what? Y output is 0. You can write it, is it? You got Y also output as 0. When A is 0, B is 0, Y output is 0. So C input may be anything, doesn't matter. Okay, C input may be anything, you get output as 0. Yes or no? So I write 0 here. Okay, and next one you see, next thing here. Let us go here now for this particular thing. I'm going to concentrate here. So here see, you have AB 0, A 0, B is 1. A 0, B is 1, is it? So this is the thing. Okay, what output you get? 1 0, 1 0. See, you may be confused which one to enter, whether to enter 1 or 0. See here, when C input is 0, you get complement of 0. What is that? 1. When C input is 1, you get complement of 1. That is 0. That means what? Depending on C value, is it? Y output appears there. So Y output appears based on the C value. So that means what? You can write it as C bar. Can I write Y output as C bar? How I can write C bar? See there, when C is 0, you get complement of 0. That means 1. Okay. So Y output depends on C input. So what is Y? Y I can write it as C bar. if if C is, so think that now C is 0, what I am going to write in Y, that is 1. If C is 1, I am going to write Y output as 0. So that is what I want to write here. So this is the main thing you have to understand. Okay. Next, let us see one more thing. That is, I am going to take this into consideration. So same AB variable has got 1 and 0 values, and here if you are seeing the output Y, it is 0. So anything C input may be, C input may be 0 or 1, anything it may be, it doesn't matter. Y output is 0, so I can enter it as 0 here. Okay, so this is one more thing you can understand. And next thing is, next last step we have, that is AB is 1 1. What happens to the output? Y is also 1. So that's why I write AB as 1 1. I enter. So whatever may be the C input may be 0 or 1, you get output as 1 itself. So that's why we enter it as 1. So now what you can see in the EVM table, you can see that there are two variables as the input and one variable as the output. Okay, so based on this I am going to write the K map now. K map. Okay, so how to write K map? So A B variables you have actually, so only two variables you have, and one more variable will be entered to the K map. Okay, so that's why I take A bar, B bar, B. Okay, so that's what. And when AB is 0 0, AB is 0 0, you write Y output as 0. When AB is 0 1, AB is 0 1, you get C bar as a, that is C bar you have here. So C bar as a output. And when A and B is A is 1, A is 1 and B is 0, you get 0 as the output. And when A is 1, B is 1, you get 1 as the output. So this is what you can see here. So if choose an A as a map entered variable, write the corresponding entered variable map. So how you can write this? So now you are going to choose A as a map entered variable. You see here, I am going to take A as A term or A variable into the K map, is it? And BC as the input variable. So suppose that is the case, how you will be getting the answer. Okay, if that is the case, BC and Y output you see here, BC is 0 0, Y output is 0. BC is 0 1, Y output is 0. BC is 1 0, Y output is 1. BC is 1 1, that is Y output is A. Okay, so this is the truth table you have, and for this corresponding to that, if you write the K map, you get it as entered variable map as this. Okay, so this is one kind of problem. So it is not necessary that the C term has to be entered to the entered variable map. Okay, you can take any term, any variable, you can enter to the entered variable map, and remaining term you can take as a input variables. So if you choose B as an entered variable map, how you are going to get the K map? Let us see. See, that is I have now taken A and C and Y as the output. Okay, A and C as the input variable, Y as the output variable. So in that case, you get the solution as 0 0. If A is 0, C is 0, Y output is 0. And if A is 0, C is 1, you get B bar. Okay, and if A is 1, C is 0, you get B, and A is 1, C is 1, you get Y as the output. So this corresponds this, let us take one more problem here. This is similar to K-map method. So as I said, you have in the previous problem, you had AB as the input variable and Y as the output variable. And here output was 0, C bar is 0 and 1. Is it? So now if I write in reduced form, I can take the truth table in this manner. Is it? The same thing is being written here. Okay. And K map for the problem is, now you are going to write, that is A and B is the input. So what you can enter here? So C bar is the entered variable mark, entered variable, or EV we call, is it? So now you have to write the final expression for this particular problem now. So how do you write? That is Y is equal to BC bar plus AB I have written here. So how do you get this particular answer now? So you may be thinking how to get this answer. So let us take the problem, look into the problem now. So here, 1 is being encircled in this manner, and C bar can take any value. It may depend on the AB values. Is it C bar? So that's why what you can write is, you can encircle this one with C bar. Okay, one with C bar value, because C bar value depends on the values of AB, so it may be 0 or 1. So that's why we are going to consider here and circle, take C bar as 1, value 1, and I'm going to encircle in this manner. So that's why you get it as B. You already you have A bar changes to A. That's why uh, you can write for this particular thing, you can write C bar, and one more term whatever you have here, that is B. Okay, that you can write, and expression for this can be written as A and B. Okay, so this is what we are going to write in the final expression. Y is equal to B C bar plus AB. Okay, note that C bar is grouped with 1. To get larger group as 1 can be written as 1 is equal to 1 plus C bar. So the product term representing each group is obtained by including map entered variable in the group as an additional AND term. So here I have taken BC as the input now and A as the entered variable map. If that is the case, how I can write the expression now? Okay, so that is here it is Y is equal to BC bar plus AB. How did you get this answer? That is initially if you are taking this term, it is BC bar. It has both variable B and C bar. So that's why BC bar you can write. And one more term that is here you have no, that is you have A, along with that you have B, no? So that's why we write it as B. So BC bar plus AB you get answer. Next problem. I am going to take A and B as a input variable and C as a map entered variable. If this is the case, you have got, if this is the K map you have got, how you write the expression? How do you write the expression? So here in this case, I can take BC bar for this particular problem, and for this you can write it as, so one term whatever you have here, that you have to take, other term which is present inside that has to be considered. So it is AC. One term is here. Okay, that I'm going to write. Another term which is included in the K map, that you have to have. So y is equal to AC bar, AC plus BC bar you get. Okay. By using map-entered variables, the K-map techniques can be extended to simplify functions with more than 4 or 5 variables. So any kind of problems can be solved here. Below shows the 4 variable map with the 2 additional variables entered in the squares in the map. Okay, here this is a textbook problem that I'm going to consider. So here G of A, B, C, D, E, F you have. So A, B, C, D is the normal terms you have. E, F I am going to take as entered variable map. That is what in the expression if you see M0 plus M2, it is M0 plus M2 plus M3, and it is also includes the entered variable map, that is EM5, mean term 5, mean term 7, mean term 9 are the entered variables. Okay, that also I'm going to include here. And also you have some don't care terms that I'm going to not going to write here inside the K map. Okay, so this is a so for this particular problem I got the K map in this manner. Okay, so some terms E, something you have here E, okay, E, F, all these are entered variables. Okay, and some don't care conditions also you have, that is represented by X here, or cross mark you can say. Okay, so from the previous slide, whatever the K map you have got, the same thing is being written here. Same K map I have brought it here, and let us solve the problem now based on the values of E and F, entered variables. So suppose I consider E equal to 0. Think that E is equal to 0 and F also equal to 0 in the first case. What happens? What happens to the problem if F is equal to 0? So this term you don't have. Okay, we don't have these terms. E is equal to 0 and F is also 0, so this one you leave. So how you can encircle now? Start encircling. If you have that x can take one value. Okay, because it is a don't care condition, so that's why x can take one. Since x is equal to 1, you can encircle in this manner, or it becomes a quad. And next you have to encircle once, you can encircle in this manner. Okay, so what is the expression now? It is a bar b bar. Okay, this is for this a bar b bar I have written. And for this term what I'm going to write is plus a c and d. Okay, so this is the thing or final expression we are going to write. And next you have suppose the second problem, let us see the second case. So let us see this. This is um, summation of first expression you got. Let us take one more problem, that is with the entered variables E is equal to values E is equal to 1 and F is equal to 0. If this is the case, how you can answer them? So E is equal to 1 and F is equal to 0. That means only this term is not there here, is it? So I'm going to encircle now. Take x as 1 if you want to encircle, and E is 1 already. Okay, so that's why I can encircle in this manner. To include this 1, I am going to encircle in this manner. Okay. F is equal to 0 and E is equal to 1. E is equal to 1. I can write it as S naught equal to A bar D, and rest I'll take here all this as X. Suppose this is X, you can write in this manner. Okay, and one more expression you have, that is when I take E is equal to 0 and F is equal to 1, what will be the solution? So here, if F is equal to 1, to include F in the expression, I can take as the expression as S2 is equal to AD. So this is the final expression. So these are the solutions, three different solutions when in different cases of E entered variables. Okay.